Alright, welcome back folks. Today is the 5th day of solving the daily Leetcode problem. So the Leetcode problem is checking the array is good or not. So we are given an integer array of nums. We consider an array is good if its permutation of an array is base n. So base n of the permutation mean like is sequentially set in order in some proportional order. Let's say like we are given like the array of 1, 2, 3, 4, 5, 6 that consider permutation. How about like 2, 4, 6, 8, 9? That's also the permutation. And then we need to consider that our array of lunch must contain the additional one arbitrary values, which is n minus 1 exactly. So according to their given information, so we're given like array of 4 numbers in given array, and then we can see like starting from 1, 2, 3, then the last number will be the double. So we have to return the true if the given array is good. If not, just return the false. And then there's an explanation about a permutation of integer represent an arrangement of these number. So let's check the constraint. So it's good that we can start the constraint with the 1 to 100 maximum. Of course, it's an easy problem, so it should be the minimum range of the constraint. And then the number could be between 1 to 200. So let's check the 4 examples together. So in a given here, we can check, okay, how about we sort that like 1, 2, 3. So we're missing the last 3. So that is not, the array is not a good situation. So how to make this good? So if I have to write that down, will be 1, 2, 3, 3. So that will be the output will be the true. So let's move on to the second example. So 1, 3, 3, 2. That's exactly what we want. It's a good array. So let 1, 2, 3, 3. But they could given us the nums array in any order. And example 3 is we're given like 1, 1. So according to the limit, the length of the array could be 1 to maximum of 100. So if 1, 1 is considered like true because the maximum element of the array is 1 and the only candidate we need to double is 1. So it could create the permutation, and it's also have a double number of the array counts inside the 1. So that make us the example 3 is permutation and it's true. So how about the example 4? So we can see like 2, 1 here. That's already not the permutation. Then we could simply return the false. So let's get back to the code, and how about we sort by using the approach with the sort first. But we need to keep in mind that if we using that sort in Swift, that could go the complexity into the O of n log n, since the original sort approach of the Swift is using the O of n log n. And then we're gonna need a count. How about nums.count, as we do it the same before? So we're gonna go through like, let's call it like index to 0 through count. Okay, how about we do the -1 here, because we don't want to go all the way down to the count. Okay, what's wrong with my indentation? Alright, cool. We are in the good situation. So I will just check like if sorted is not in the order. Not in the order mean like index +1, because our index start from 0 and our given integer array start from 1. So just +1 to here. If not, then just return false. If yes, we can simply return true. Okay, what did I do? Okay, that's my mistake. Should be the index. Alright, so we are returning the one case true, which should be false. So the problem that I make wrong is I should check the let's index count is exactly the same as the total number of array. How about we check our sort depth of count, which is our less index minus 1 is equal to the exactly of count. So what I'm doing here is, okay, we're given like 2, 1, 3 in here. Let's do it. All right, we are given like 2, 1, 3. So I'm gonna sort it anyway. That we want 2, 3. Before returning the result in here, what I'm going to do is I'm going to check the second last index of here is exactly same as the count. So let's consider this is 3. So it should be 3. So if it is 4, our array is not good. So what about like this? So we check in the here. And then what that will make it like so we have a valuation of count is 3 because we have a detection of -1 in here. So that would make us 4 minus 1 since the total count is 4 in here. So 4 minus 1 is 3. So we're gonna go through the number of array 3. So 0, 1, 2, 3 is this one. We're gonna go all the way to here and then we're gonna check. So the last number is exactly the same as we expected or not. All right, hope you guys got it, and then let me try to submit it. All right, it's pretty much in a good situation, but I think I can do much better if we want. So let's check the analytics from the Leetcode. So the runtime will definitely take the O of n log n because we are taking the sorted in here. So for the memory, it's taking just O of n. So we could make it O of 1 if we want. How do we do it? Let's try to tweak a little bit. What if instead of using the sort, how about we use the approach like set? So, but we definitely need the count in here. I'm gonna put all the nums in the set. So set is a data structure that could help us to clean up the duplicate numbers. So we are expecting like, let's say if it is a 1, 3, 3, 2, we will only receive like 1, 3, 2 or 1, 2, 3 in any order. So after we receive the set, I'm going to check the occurrence. Let's call like occurrence. That will be we need to filter it from the number. Well, what do we check? What we check is every single number in the nums is similar to the count -1. So what I mean by count -1 is, let's call it we have a number 4 because our total count is 4 in here. So 4 minus 1 is 3. So I'm gonna fit out how many maximum 3 we could find in here. So that's my approach. So the final result will be occurrence must be equal to 2 and our set num total count must be count -1 because we want to double check the output of the set and the occurrence is doing exactly as we wanted. If yes, just return the true. If not, return the false. Let's try locally first. So yep, let's try to submit it. I feel like I'm missing the one case. I cannot think of it at the moment right now. All right, that's what I was waiting for. So even though we have able to sort it properly, but the number we are receiving is not the permutation number. So how do we do it? It's quite simple. How about we get the max of the array? That should be count minus 1. So technically we're counting like, okay, we have 3. So the max should be definitely 2, not 14. So if something wrong, we can easily return the false. Alright, I think I can adjust the minus 1 here because I'm doing minus 1 a lot in almost like every place. Just use the count in here, same count here. Alright, cool. Yep, for the sake of clarity, code is much cleaner than before. So if I have to measure, so the time complexity will be the O of n and the space complexity will be the O of n also, because we're using the extra filter in here that's going through O of n. Alright, that's pretty much for it, and then see you in the next one. Bye.